Bindusree, working as an assistant professor in the Department of Electronics and Communication Engineering at Institute of Aeronautical Engineering. Today we'll discuss about the K-map method up to the 4 and 5 variables. So today we'll discuss about the limitations of K-map, procedure and example problems. So generally we are taking any Boolean expression. So using this Boolean algebra, it has simplified the expressions and the circuits. Some extension only we are using the some theorems and the properties. So after that we want to simplify the Boolean expressions. We want to reduce the literals. So we are using the K-map method. That is the Karnaugh method. So generally we are taking any Boolean expression. We want to simplify that Boolean expression. We want to reduce that Boolean variables. So generally we are using the properties and theorems. So in this Karnaugh map, we want to reduce the Boolean expressions. So by using this graphical technique, we want to simplify that Boolean expressions. So K-map means a graphical technique for simplifying a Boolean expressions. So these K-maps are the two types: minimum sum of products and the minimum product of sums. So that means sum of products. If you are taking the any Boolean expressions, we are taking the some product terms. That product terms we are having the sum. So that is the sum of products. Next one is the product of sums. So here we are taking the some expression. So that is the AB plus BC plus some AC is there. So AB is the one product term, BC is the one product term, and AC is the another product term. So this product term sum is the sum of products. So if you are taking the A plus B into B plus C into A plus C, so this is the sum of product terms. Okay, so this is the sum of product terms. This one is the product of sum terms. Okay, so we want to simplify these expressions. So here we are using the minimum number of product term and the sum term. Each term has a minimum number of literals. We want to reducing the literals in the practical cases. So if we are constructing the any circuit, so that propagation delay is the very less and the fan is the very less. So we want to reduce that one. So we want to reduce the literals also. Okay. So for example, we are taking the any truth table. So in the truth table, we are taking the any truth table that contains the all possible values of the input and output values. If you are taking the any input values, so for that input variables, we are getting the some output value. So the values are stored in the cells of the array. So in each cell, a boundary value of the each input variable is stored. So in this K-map, we are having the 2 variable, 3 variable and the 5 variables. So more than the 5 variables. So this K-map method also the complexity. Then we are going to use the Finn-Minkleski method. Okay. So more than the 5 variable method, we are using this method. So the number of cells is similar to the total number of the variable input combinations. So here in this K-map is the graphical representation of that one. So that graphical representation of that cells are depending on the number of variables. So if you are taking the n equal to 2, so how many combinations are there? 4 combinations are there. So in this K-map we are taking the 4 cells. Okay. For example, if the number of variables is 3, so the number of cells is the 2 power 3 equal to 8. So here number cells is the 2 power 3 equal to 8. So total the squares are the 8 boxes are there. So if you are taking the number of variables n equal to 4, so 2 power 4 equal to 60. So the K-map takes the SOP and POS form. So the K-map grill fill using the zeros and ones. Okay. So if you are taking the K-map. In that K-map, we are having the some cells are there. So each and every cell, we want to fill the either the 0 and the 1. Okay. So when we are using the 1 and when we are using the zeros, we'll discuss. So now K-map is solved by making the groups. Okay. So what is the procedure for reducing that literals? So what are the product term and the sum term we are taking? So how can we reduce that literals? We'll discuss now. Okay. So in this one, we have to follow the some procedure. So first one is we find the K maps. We find the K maps as per the number of variables. First, we find the K map as per the number of variables. Next one, find the max term and min term in the given expression. Okay, so in this one, first we find the K map as per the number of variables. So that means if the number of variables, if n equal to 2, 2 power 2 equal to 4 cells, n equal to 3, 2 power 3 equal to 8, like this. So first we find the K map as per the number of variables. So next one is find the max term and min term in the given expression. So why we are finding this min term and max term? So if we are taking the SOP form, so that is the sum of product term, we are taking the min term. So we are taking the POS form, product of sum, so then we are taking the max term. So that's what we have to decide that either we are using the min term and the max term. Next one, fill cells of K-map for SOP with one respect to the min term. So if that expression is the min term, so in that particular cell we are filling with the 1. Next, so for example, we are taking the POS form. So in that block or cell, fill that with the 0. That is the max term. So in this POS term, we are taking the max terms. So in that box, if you are taking the POS form, in that box will fill with the zeros. If you are taking the SOP form, so that is the min term. So that SOP form will fill with the block is filled with the 1. Okay. Next, we create a rectangular groups that contain total terms in the power of 2, like 2, 4, 8. Okay. So as many elements we can in one group. Okay. So we want to reduce these expressions. So here we are using the some groups. By using the groups, we can reduce that literals. So that groups are the either the 2 and 4 and 8 like this. So with the help of these groups, we can find the product terms, sum them up to the for the SOP form. So for example, we are taking the 2 variable K map. So here the number of variables is the 2. Number of variables is the 2. So that number of variable is assigned with the n equal to 2. So how many groups are there? 2 power n. So that is the 2 power 2 is the 4 groups. Means, so here we are using the 4 blocks. A 2 variable function has the 4 possible min terms. 4 possible min terms. X and Y are the input terms and the min terms. So, X equal to 0, Y equal to 0, 0, 1, 1, 0 and 1, 1. So, in this SOP form, if the 0 is there, we are taking the bar. That is the inverter. So, X and Y is there. So, that is the X bar, Y bar. Next, 0, 1, X bar, Y. So, if the 1 is there, that is the true form. If the 0 is there, that is the complement of that particular variable. So, similarly 1, 0. So, X equal to 1, Y equal to 0. So, X, Y bar. Next one, 1, 1. So, that is the X. So, here we are taking the 4 blocks. So, this is the K map, 2 variable K map, 4 boxes are there. So, in this one, so in this X we are having the 0 and continuously we are having the zeros in the X variable and continuously 1 in the X variable. So, that's what in the left hand side, that is the horizontal side, we are taking the 0 and 1. So, that is the X variable. So, similarly in the Y side, we are taking the 0 and 1. So, that is the Y variable. Okay. So, 0, 0, 0, 0. So, in this box, we are having the 0, 0. So, that is the X bar and Y bar. Next one, 0, 1. So that is the x bar and y. Next one 1 0 xy bar 1 1 xy. So this is the two variable K-map. So in this block we are having the 0. In this block we are having the 1. In this block 2. In this block 3. 0 1 2 3. Okay, this is the two variable K-map. So now how can we are forming the one group? We'll discuss this one. So we can easily see which minterm contain the common literals. Okay, so minterms on the left and right side contains y bar and y. Top and bottom rows contains the x bar and x. So this is the, here the 0 is there, so this is the x bar. So here the 1 is there, this one is the x. So similarly here the 0 is there, that is the y bar, 1 is there y. So x bar y bar, x bar y, 1 0 xy bar and the xy. So make a few rectangles as possible to minimize the number of product of the final expression. Okay, so how can we are forming the one group? So we'll discuss that one. Each rectangle as large as possible to minimize the number of literals. Rectangles can be overlapped if that makes them larger. Okay, so we'll see that one. So for example, if you are taking this two variable K-map, so now I want to form the one group. Now I want to form the groups. So how can we are forming the group? So adjacent number of the square boxes only we are forming the group. So how can we are forming the group? So adjacent number of the square boxes only we are forming the groups. Either these two square boxes or these two square boxes. So if you are including this first box, either we can form this is the one group, and either we can form this is the one group. So similarly, if you are taking this one, so we can form this is the one group and this is the one group. Either we are taking this square box, we can form this group and this one. Similarly, this one, so either form this group and this group. So we cannot form the group in the diagonal square boxes. Only we are forming the groups in the adjacent number of the square, square boxes only. We cannot form the group in the diagonal form. Okay, so that means, so if you are taking that, if you are having the any Boolean expression, so if that expression is if f equal to x bar y bar plus x bar y is there. So this is the one Boolean expression. So in this one we are having the x bar x and y bar y. Okay. So in this first one x bar and y bar is there. So this is the x bar y bar. This is the one group. So here we are taking the SOP form. That's what this block will be assigned with the 1. So next one is the x bar and y. So this is the 1. So here we are not having any expression is there. These two square boxes are empty. So using the zeros. Okay. So adjacent number of the ones are there. So these two are the adjacent square boxes. We are having the ones. So we can form the one group. Okay. So if this one is having here we are having the one more group. So that means either that expression is like this. So we can form this is the one group. Okay, this for example we are having this one is there, xy is there. So if you are having the xy is there, so we can form this is the one group. So we cannot form this these two are the, so these two square boxes are the diagonal form. So we cannot form this is the, we cannot form the group in these two ones. So either we can form this, these two ones and these two ones. So we cannot form this, these two square boxes as the one group. So now I want to write the expression for these two groups. So this is the one group and this is the one group. So this is the one group and this is the one group. So now I want to write the, simplify this expression. So this is the first group. This one is the second group. So in this first group, First we have to check in the left hand side, so that is the horizontal side of this one. So in these two ones, in this first square boxes, in this one we are having the x bar is there, in the second one we are having the x is there. So here the complement of this x is there, here the true value is there. So no common variables, either we are having the both are the either the true values or the complemented values, then only that is the common. So in this first square box x bar is there, second square box x is there. So no common variable in this x. So now coming to this y side, vertical side. So these two two are in this one, y bar is there. So that is the common variable y bar. Okay. So next one. So we can form the group only the common variables. We are writing the only the common variables only. So next coming to this side. So these two ones are having the x only. So for this square boxes we are having the x variable is there. So for this one also same x variable is there. So that both the square boxes we are having the true value is there. Plus x is the common. So coming to this y. So here the y bar is there, here the y is there. So no common variable. No common y variable. So now final the expression is f equal to x plus y bar. So first for that expression is x bar y bar plus xy bar. So now I want to reduce this expression into the this one by using the k map. Next one, 3 variable k map. So in this 3 variable k map, so n equal to 3. So in this 2 variable k map, so if you are form the one group, so here the one also there. So this is the one group, so that is the quad. So if you are form the group in the 2 only, so that is the pair. Okay. Next one, 3 variable k map. So n equal to 3. So 2 power 3 equal to 8. So now total are the 8 square boxes are there. So here we are using the SOP form. So that is the M0, M1, M2, M3, M4, M5, M6, M1. So if for example, if n equal to 3, so if you are writing the any variables, if you are writing the truth table for this one, so x, y, z are the inputs. So that values are the 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1 is there. So observing these expressions, so coming to this x variable, continuously here we are having the zeros, continuously here we are having the ones. That's what in the horizontal side, here we are taking the zeros and ones. So in this y and z also the zeros and ones only. But here first two inputs are the zeros, next one. So alternately it will be the changing. But observing this x variable continuously, either it will be the 0 and after that the remaining values are the 1. Okay. Based on that, so here the 0, 1. So that's what in this horizontal side we are taking the x variable. Next y and z. Okay. So K map is follow the gray code. K map is follow the gray code. So this gray code is a unit distance code. Gray code is a unit distance code. So observing this one, so first here we are having the 0, 0 is there, next 0, 1 is there. After that generally we are taking the 1, 0. So we are not taking the 1, 1. So this is the 0, 0, 0, 1. After that 1, 0 and 1, 1. So that is the one 0, 1, 2, 3 like this. But here we are using the 0, 1. After that we are taking the 3 and 2. So why? Because that K map is follow the gray code. K map is follow the gray code. So observing these two expressions. So observing this 0, 0 and 0, 1. So only the single value will be the changing. 0 will be changed to this one. So 0, 0 same, 0, 0 same. So here the unit distance is the 1 only. So next observing this 0, 1 and 1, 0. So here the 1 will be changed to 0 and 0 will be changed to this one. So here the two changes are there. So gray code is not satisfied that one. So if you are observing this 0, 1 and 1, 1. If you are observing this 0, 1 and 1, 1. So in this first bit, 1, 1 both are same. 0 will be changed to this 1. So either we are taking the 1, 0. So 1, 1 both are same. 1 will be changed to this zeros. 0 1 1 1 and 1 0. So that's what. So after the 0 1 we are taking the 1 1. So after 1 1 we are taking the 1 0. So that's what M0, M1, M2 and M3, M4, M5, M6 and M7. So because here also same procedure 1 0 0 1 0 1. So after that generally we are taking the 1 0. So 0 1 and 1 0, observing this 0 1 and 1 0, two changes are there. So this is not satisfied that condition. So next one 0 1, after that we are taking the 1 1 1. So this is the three variable came. Okay. So now I want to, so this is the three variable came up. Now we are taking any boolean expression. So how can we are forming the groups? So first we are observing this 2. So 2 2 ones means, so generally we are taking the any K-map. First maximum number of possible ones are from the one group. Next coming to this, next maximum number of the ones are forming the one group. So here we can form the either all the 8 ones. So if you are taking the all the boxes are having the ones are there, so that output is the 1. So next possible combinations are the 4 ones are there. So 4 ones are there. So when we are form the 4 ones in the one group, so that is the first one M0, M1, M3 and M2. So that means M0, M1, M2 and M3. So this is the one group. Here the 4 ones are there. So this is the quad. 4 ones are there. So here we are observing this one. So how can we are writing the expression for this one? So in this left hand side we are having the 0 only. So that is the x bar. So coming to this one, we are having the no common one is there. So here the 0 0 is there, 0 1 1 1 is there, 1 0. So no common one is there, only x bar is the common. Okay, this is the possible combination of this 4 ones to the 1. Next one M4, M5, M6 and M7. So similarly, this is the another group. So here the common expression is x. Next one M0, M1, M4, M5. So either these four boxes are the one. So here how can we write the expression? So coming to the x variable, no common variable is there. So here the x bar is there, here the x is there. So here the complement value is there, here the true value is there. No common variable is there. So coming to this side, so y bar and z bar and y bar and z. So if I'm observing this y term, so here both the y bar is there. So observing this z term, here the z bar is there, here the z is there. So now we are writing the expression is y bar. Next one, M1, M3, M5, M7. M1, M3, M5, M7. So this is the another group. So here also same one. So no common x variable. So observing this one, y bar z and yz is there. Here the y bar is there, here the y is there. So no common y term is there. Y term. So coming to this one, z is there. Next one, M1, M3, M5 and M7. So this is the power. Next one, M3, M2, M7 and M6. So either we can form this is the one group. So observing this one, so no x variable is there. So coming to this one is the y. Okay, last one is there M0, M2, M6, M4. So if you are folding these square boxes, M0, M4 and M2 and M6, if these 4 are the adjacent of this one. If you are folding this M2, M6 to the this square boxes, if you are folding this one, M0, M4 and M2, M6 are the adjacent of that ones. So that's what M0, M4 and M2, M6 are the, we can form the one group. M0, M4, M2 and M6. So no x variable is there. Coming to this one, z is there. This is the all possible combinations of the 4 ones. Next, we can form the groups in the two adjacent terms. So that means either we can form this M0 and M1. This is the one group. Next one M0, M1 and M3. Similarly, M3 and M2. Next one M4 and M5, M5 and M7, M6 and M7. So similarly, M0 and M4. So already these are the all the groups are over. So either we are not form the and the group like this M0, M4, M1, M5 and M3, M7 like this. Why? Because already all the ones are from this one group. So for example, so that is the one group. Next one M0 and M4, M1 and M5, M3 and M7 and M2 and M6. These four are the another group. Okay, so if you are having this one expression, if you are having this one M5 also there, so you can form this is the one. This is the two variable K. Next one is 4 variable K-map. So n equal to 4. So how many combinations are there? 16 combinations are there. 0, 0, 0, 1, 1, 1, 1, 0. Similarly 0, 0, 0, 1, 1, 1, 1, 0. So same procedure. Here also after the 0 we are having the 1, 1, 1, 0. So M0, M1, M2, M3, M4, M5, M6, M7. So after that one we are taking the M8. So 8 value is this one. Okay, 0, 1, 0, 0, 1, 1, 0. M7. So after the M7, M6 is there. Next one. So coming to this one, M8, M9, M10, M11, M12, M13, M14 and M15. This is the 4 variable K-map. So here also we can form the 16 adjacent minterms are there. Either the row side and the column side. So first one R1, R2 and R3, R4 in the minterm, and C1, C2, C3, and C4 are this column side. Okay. So either we want to form these groups R1, R2. This is the R1, R2 and R3, R4, C1, C2, C3 and C4. So if I want to form this one group like this R1, R2. So that means this is the one. So this one is the octet group. Okay. These 8 are the one group. Otherwise R2 and R3 is the another group. Similarly R3 and R7 is the one group. Okay. So similarly C1 and C2 is the one octet. C2 and C3 is the another one. C3 and C4 is the common. So here we are observing this in this row side, no common variable is there. Only we are having the common variable in the column side only. So write that value. This is the 8 ones. So if you are observing this 4 ones, means so each and every row R1, R2, R3 and R4. So we can form the one group. Next similarly C1, C2, C3, C4, that is the another group. So M1, M5, M3, M7, M0, M1, M4, M5 like this. So otherwise remain terms are the M0, M2, M8, M10. M0, comma, M2, comma, M8, comma, M10. So this is the one group. Either M4, M12, M6, M14. M12, M6, comma, M14. Either M9, M11 and M1, M3. So either from the R1 and R7 also the one group. Okay. Similarly, M3, M2 and M10, M11 also one group. M0, M1, M8, M9 also another group. So we can form this different groups are there. So coming to this 5 variable K-map. So 2 power 5 equal to 32. So total square boxes are the 32. So each and every box we are having the 16 combinations are there. So 16 plus 16, 32. Okay. So here we are taking the variables is like this A, B, C, D, E. So in this truth table, we are writing the 32 decimal values. We are writing the some binary values. From 0 to 15, the MSB value is the 0. So 16 to 32, the MSB value is the 1. So that's what this MSB value is the 0. This is the square box. Here the MSB value is the 1. This is the another square box. So that's what. So after the M15, here we are writing the M16, M17, M18, M19. 20, 21, 22, 23, 24, 25, 26, 27. So in this is how can we form the groups in these two different variable K maps? Okay. So in this one, so in this first we are observing this first K map method. So here we are having the any ones in this group. For example, this M5, M7 and M13 and M15 are the one group. In this V equal to 0, that is the MSB value is the 0. So coming to this one, so here also in the same place we are having the ones is there. So we can form this, these two are the one group. So here the 8 ones are there. So now no common MSB value is there. So only observing this left hand side and right hand side only. So here also same values are there. So if for this one the expression is X and Z. X and Z. So same place we are having the ones are there. So same we are from the one group in the if the ones are presenting in this first square box, some ones are there. Same ones are presenting in this V equal to 1 also. We can form the one group, but no common variable in the MSB value. So that is the V equal to 0 and V equal to 1. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.